Good morning, everyone. Today we are going to learn about the remaining interview questions of VLSI DFT. So these all are the series of lectures. Please share and subscribe my channel. So we'll get updates all the interview questions and DFT related topics. Uh, my question is how to toggle reset to get coverage. If the reset is asynchronous and properly bypassed during the scan, you can declare the reset pin as a clock during ATPC, and ATPC will toggle it accordingly to get the faults on reset. That means if we declare the reset as a clock during ATPC, we can toggle it, and the faults on the reset pin also covered. If reset is synchronous, that is the case, you can treat reset pin as a normal data pin, and ATPG should be able to cover faults on reset. Yeah, here one caution, be careful. However, if you run transition fault ATPG, reset usually cannot toggle at speed. So you may not want to declare the reset as a clock when running the transition fault ATPG. You can also try to run patterns that toggle the reset as a clock pin at a reduced speed on the tester. If you worry about the transition fault coverage on the reset. Finally, what is going to tell that reset, if you declare the reset pin as a clock, then we can able to cover the faults on reset pin. This is applicable for only the asynchronous reset. For a synchronous reset, reset is connected to the data. You can treat the reset pin as a normal data pin, and ATPG will able to cover the faults on reset. The next question is, what is difference between test pattern and test vector? Yeah, actually these two terms are interchangeable terms. I tended to say that a test pattern is a set of test vectors. Our ATPG tools generally give you stats that claim a certain number of patterns, but personally I would call them as vectors. Test patterns are used for ATP. A term test pattern is used in ATPG testing DFT. Test vectors are used in verification. Maybe those two are the interchangeable. My next question is, what is the difference between the sequential and combinational ATPG? Combinational ATPG simulate one clock pulse on the circuit. Sequential ATPG simulate multiple clock pulses. When scan enable is low, the combination ATPG will have only one clock pulse. When scan enable is low, the sequential ATPG will have two multiple clock pulses, more than one, during the capture. Next question is, how the compression technique factor affects the number of scan chains? Is the number of clock domains also the factor? Yes, definitely. Clock domains are also a factor, yes, but sometimes people will combine the clock domains into a same scan chain. That means within the same scan chain, we have two different clock domains. Such a case that is not uncommon and will work if the clock skew is managed and the tool will put lockup latch is there. If the single scan chain, different clock domains are there, the tool will automatically add the lockup latch to prevent the data loss. Compression affect the number of scan chains. Of course, yes. Since more compression generally uses fewer external scan chains and external scan chains. Normally, these external scan chains are called scan channels. So internal scan chains, we call it as a scan chains. Okay. My next question is, how to decide the number of scan chains? This is one of the important question. The number of package pins available for scan IO. Size of the design. These two are the major factors. EDA tool available for use. Targeted AT, the test runtime desired. So these are the secondary things, but the major thing is number of IO pins and size of the design. Okay, they are all interrelated. You can start usually with the first two, try to figure out the whether or not you are going to fit on your targeted tester and go for uh, there, make the trade-off. It is a trade-off. Tester time, number of IO pins, size of the design. Okay, thank you all. We'll meet our next video for remaining interview questions. Please share and subscribe my channel.